we're going to look at section 1.5, and this is going to be on quadratic functions, quadratic equations, and how to solve them. We're going to look at several methods to solve them. So let's look at this first problem here. First off, let's write that a quadratic equation is of the form ax squared plus bx plus c equals 0. So one of the things we're going to notice is, okay, we want everything on the left in descending order of powers. So x squared first, then x, then the number, then equal, then 0. So if I look at problem 1, we notice that it's not in that order. So we need to move this 27 over, and we need to move this 81 over. And when we do that, they're going to become negative. So we're going to have minus 27x minus 81 equaling 0. Okay, now I'm going to show you a method to factor this. So we're going to try to factor this. And I'm going to show you the AC method. You probably had seen this in intermediate algebra. So the AC method says take A times C and look for factors that add to B. So we're using all three numbers here. We're going to multiply our A term and our C term, and we're going to see the factors of that number that combine to be minus 27. So let's outline what we have here. So A is 4, C is negative 81, and we're going to try to find a way to get those to combine to be minus 27. Okay, so let's take 4 times negative 81, and if you do this, you'll get negative 324. And now we're going to look for the factors of minus 324 that add up to minus 27. So let's write minus 324 over here, and let's look at the factors. So we have minus 1 times 324, we have minus 2 times 162, 3 will work, I didn't write it down, I think it's 108 times 108, and then 4 will work, minus 4 times 81, 5 doesn't work, 6 will work, minus 6 and 54, 7, 8, 8 will work, I also did not write that one down, but 9, let's try 9, you get 36. So you can kind of systematically do this. You just take your number, 324, and you start dividing by 1, then 2, then 3, then 4, and you write down. So all of these factors here multiply to become minus 324. But what we're looking for is, what do they add up to? So if I add these two numbers, I get 323. If I add these two numbers, I get positive 160. If I add these two numbers, I get 105. If I add these two numbers, I get 77. If I add these two numbers, I get 48. If I add these two numbers, I get 27. Now let's stop there. That's real close. 27, we wanted minus 27. So all I have to do is swap the minus sign and call this negative 36. And now those two do add up to negative 27. Okay, so we found the winning combo. It's 9 and negative 36. Okay, now what you do is, in the AC method, you keep your A term the same, you keep your C term the same. But the B term we're going to write not as negative 27, we're going to write it as negative 36x and plus 9x. So you can confirm those two, we haven't changed the problem, because if you do add those two numbers, you get negative 27x. But now what we're going to do is we're going to say, okay, we're going to do what's called factor by grouping. So we're going to group these two numbers together, and we're going to group these two numbers together, and we're going to look for common factors. So if I look at the first two numbers, 4x squared and minus 36x, Notice they can both be divided by 4, and they both have an x in them. So we're going to factor out 4 and an x. What's left is x minus 9. Just dividing negative 36 by 4, and the x gets stolen away. Now this plus symbol, the blue plus sign, drops down. Now look at 9x and minus 81. They can both be divided by 9. So you factor out a 9, and you get x minus 9. Okay. This should always happen if you've done this correctly. You should get two bubbles, two parentheses that look exactly the same. And now what we can say is, okay, factor that out. So let's factor out this common x minus 9. And we're going to get two bubbles. One is the x minus 9. In the second bubble, you write whatever's left. So what's left is 4x plus 9. 4x plus 9. And we're still setting all this equal to 0. Okay, so that's the hard part, is the AC method, trying to get the factoring correct. But once you do it, and then you do factor by grouping, you can quickly get to this factorization. Now, there's more than one way to do this. This is just one way to do it. Okay, now, we're not done, though. To solve this, we're going to set this equal to 0, and then we're going to set this one equal to 0. So we're going to start with x minus 9 equals 0. That one's pretty easy. Just add 9 to both sides to isolate x, and you'll get x equals positive 9. So that's one answer. This next one's a little trickier. Let me write it up here. We have 4x plus 9 equal to 0. The idea being, if either of these two bubbles is 0 because it's being multiplied, it's going to wipe out everything. So if any of these two bubbles is 0, the whole thing is 0. So we just have to solve both of them. So on this one, I'll subtract 9 from both sides and get 4x equals minus 9. And then I'll divide both sides by 4. And we'll get 1x equals minus 9 over 4, which doesn't simplify. So we have minus 9 over 4. And I should note, in a quadratic equation, you always get two answers. So we should always get two answers for these problems. And we found the two that work for this one. Okay, in problem 2, it's a little different. We've got a factored left side and a non-factored right side. So what we're going to want to do is, just like before, we're going to want to get everything to the left side, and then we can try to factor and see what the answer would be. So first we're going to distribute this 2x. So we're going to want to make everything look like this. ax squared plus bx plus c equals 0. So that's what we want. So let's see. 2x times x would be 2x squared. 2x times negative 3 would be minus 6x. And that's going to equal 6x squared minus 9x. Okay, now just like before, I'm going to move these. So to move them, I'm going to subtract 6x squared from both sides. And we're going to add 9x to both sides. 2 take away 6 would be minus 4x squared. Minus 6 plus 9 would be plus 3x. And the right side is completely wiped out. It's just 0 now. Now we look at these two terms and we say, okay, what's common between those? Well, 4 and 3 have no common factor that we can pull out, but they both do have an x. So let's pull out 1x. So we're going to be left with minus 4x plus 3. Okay, and that is the factored form, so we can't simplify that anymore. And now is the stage where we're going to say, okay, we have to solve when this equals 0, and we have to solve when this equals 0. Okay, so the first one, we set x equals 0, well, that's the answer. So if x is 0, that would wipe out anything in this parenthesis, so that's one solution. But now we have to set minus 4x plus 3 equal to 0. And we will subtract 3 from both sides and get minus 4x equals minus 3. And then we will divide both sides by negative 4 and get 1x is equal to minus 3 over minus 4. But because of the double negative rule, those two negatives can cancel and you just get 3/4. So we have two answers. If x is 0, or if x is 3/4, those would both make this original statement true, or it'll make the quadratic equation, once we move everything to the left-hand side, equal to 0. Okay, for problem 3, we're going to use what's called the square root property. And this says, if you have x squared equal any number p, then x is just equal to plus or minus the square root of p. So if we do a quick example, if I have x squared equals 25, then we know x is equal to plus or minus the square root of 25, which is plus or minus 5. Now, why do we add that plus or minus? We add it because when you're squaring things, negatives go away. So if I have 5 squared, that produces 25. But if I have minus 5 squared, that's the same as taking minus 5 times minus 5. These two negatives will cancel, and you also get positive 25. So the square root property takes that into consideration. It says, well, negative numbers will work as well, so that's why we add that plus or minus. Let's box this. Okay, so if we look at problem 3, it's really close. It's not quite there, though. So what we want is just x squared on the left and just one number on the right. So to start, we're going to first subtract 7 from both sides. The 7's will cancel there. I'm left with 5x squared. On the right, I'll get 22 minus 7, which is 15. Now, we're also still close, but not quite there. Notice there's no number in front of the x squared equal to p. So we don't want that 5 there either. So to get rid of that 5, remembering that it's multiplication, to undo that, I must divide. So we divide both sides by 5, and we get x squared equal to 3. Okay? And now it's exactly in the form. So we have x squared equal p. The answer will be the square root of p. So if x squared is 3, then x is plus or minus the square root of 3. Since the square root of 3 is not, doesn't have any factors that are perfect squares, so that would be our answer. In fact, in your homework you would type minus square root of 3, comma, just regular positive square root of 3. 4 is actually really similar, but I had a lot of students in my face-to-face class that kind of went the wrong way with this. So they were trying to expand this square, the x plus 7. So they were, well, let's just show you. They were trying to do this. X plus 7, and then equal 90. And then they were trying to FOIL this and distribute the 2 and subtract. It's a lot of work if you do it that way. So we don't want to do it that way. What we want to do is try to use that principle we just learned about. We want to try to use the fact that if I have something squared, in fact, let me write it like that. If I have something squared equal a number, then I can get this by itself if I just square root both sides. So to do that, the first thing we have to do is get rid of this 2. So to get rid of that 2, we have to divide both sides by 2. And we'll be left with x plus 7 squared equals 9 divided by 2, 45. Okay, now this is this. What I just wrote up here is going to work. So I have something squared equal 45. Well, I can make that just something by itself if I take the square root plus or minus of 45. Okay, so square root, in essence, what I'm doing, and I'm not quite showing it, is this. I'm saying, okay, to get rid of this 2, I have to square root this. But if I square root the left-hand side, I have to square root the right-hand side. And anytime you're writing a square root, add the plus or minus. Okay, so that's what we did. Okay, now I can drop the parentheses because it's not being squared or anything's being done to it. So I just have x plus 7 equals plus or minus the square root of 45. And now I want to isolate x, so I subtract 7 from both sides. Now be careful. Minus 7 and a square root number are apples and oranges. You cannot combine those. So you're just going to write minus 7 plus or minus the square root of 45. Now the square root of 45, you can factor that. So if I look at the factors of 45, 1, 45, 3, 15, 4, 5, and 9, and that's where I can stop. So when you look at these factors, if any of them is a perfect square, like 9, 9 is really 3 squared. That will come out of a square root. In fact, let me show it this way. So I can break 45 down into its two factors. So I can have x equals minus 7 plus or minus the square root of 9 times the square root of 5. So you can break 45 into its two factors of 5 and 9. But they both have to have a square root on them. And now I can say, oh, the square root of 9 is 3. So this will simplify to minus 7 plus or minus 3 times the square root of 5. And that is the final answer. So you would type this in like minus 7 plus 3 square roots of 5, comma, minus 7 minus 3 square roots of 5. And there's your two answers. Okay, for 5, we're going to create what's called a trinomial. A trinomial has 3 terms from a binomial, which is 2 terms. Let's write this. So we have a binomial, which is 2 terms. And we want a perfect square trinomial, which will have 3 terms. And our goal, a perfect square trinomial, is something like this. It's x plus something squared, plus or minus something squared. Okay, so that's what we're trying to do. Now I'm going to teach this with a pattern, and hopefully you'll catch on pretty quick. So if I have x squared plus 2x, it becomes x plus 1 squared. If I have x squared plus 4x, it becomes x plus 2 squared. If I have x squared plus 6x, it becomes x plus 3 squared. If I have x squared plus 8x, it becomes x plus 4 squared. And this is about where I'd say anyone would see the pattern. And then I would say, what's this one? X squared plus 10x. It becomes x plus 5 squared. So how am I getting these numbers? I'm just having this second number. So half of 2 is 1. Half of 4 is 2. Half of 6 is 3. Half of 8 is 4. Half of 10 is 5. If I have x squared plus 17x, it becomes x plus 17 over 2 squared. So 17 can't be halved perfectly. It's not a number. But you just have it. So you'd say 17 divided by 2. That would be the thing that goes in this perfect trinomial. This is pretty good, but there's a problem that occurs, and that is if I were to FOIL this out, in fact, let's look at the problem that we're working on, which is right here. If we were to FOIL out x plus 3, it's really the same as x plus 3, x plus 3. Okay, now let's look at FOIL. So FOIL stands for first, outer, inner, and last. So the first two terms are x and x, so we get x squared. The outer two terms are x and 3, so we get plus 3x. The inner two terms are x and 3, so we get another 3x. And the last two terms are 3 and 3, so we get plus 9. So we get x squared plus 6x plus 9. If we look back at this original binomial did not have that 9. That 9 is extra. So we picked up an extra 9, where this did not have that. So to turn this binomial into a perfect trinomial, I just have to add 9. If I add this 9, then I can rewrite this whole thing as our perfect square trinomial, x plus 3 comma squared, or x plus 3 parentheses squared. So to solve this problem, it's going to say, okay, what number do you add? We add a 9. What does the trinomial become? It becomes x squared plus 6x plus 9. How does that factor? That factors into x plus 3 parentheses squared. So, and we can prove that if I FOIL this out, I will get back to this term, this trinomial. So to make this binomial a perfect trinomial, just add a 9. Now this is also a pretty easy pattern to hopefully see. If I had x squared plus 2x, I would add a 1. If I had x plus 2, I would add a 4. If I have x plus 3, I add a 9. If I have x plus 4, I add 16. If I have x plus 5, I add 25. And if I have 17 over 2, I would add 17 squared over 2 squared. So the number you add is just these numbers squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. So hopefully it should be a pretty quick problem once you see this pattern in action. Okay, so problem 6, if we use that pattern we just established, it should be pretty simple. So I want to form this into a parentheses where I take x, half of that number, so minus 7, I square it, but then I'm going to pick up this number squared. So this is going to add, this one is going to be different than this one. It's going to have an extra 49 on it, which is minus 7 squared. So I have to add 49. The trinomial becomes x squared minus 14x plus 49. And that factors perfectly into x minus 7 squared. So these problems can be pretty quick if you know the routine. You just have the second number, and then you add to that the overall equation, the overall expression, that halved number squared. So 7 squared is, in fact, it's negative 7, but in fact, let me write that. So we got this number by taking minus 7 times minus 7. The double negatives cancel, and you get positive 49. Okay, for 7, it wants us to do the same thing. It wants us to use that same pattern. So it's going to say, okay, rewrite that x squared minus 6x into a bubble that is something squared, and then we're going to equal that minus 6. So if I write this as a perfect square trinomial, I'm going to have half of minus 6 goes here, so minus 3. But we know if we FOIL this out, in fact, let me write this. If I were to FOIL this out, I would get x squared minus 3x, which is minus 6x. But we would also get minus 3 times minus 3 is plus 9. So notice, on the left side, we don't have exactly the same as what we started with. We added an extra 9 by writing it in this factored form. So to account for that plus 9, we have to plus 9 this side as well. Okay, and I have students that want to subtract the 9. Say, well, to get rid of that 9, I don't want it anymore. Let's subtract it. Well, we have to pick up that plus 9 because of this factored form that we like. We like this bubble squared because then I can use the square root property and solve problems really fast. So that 9 is going to be there. It has to be there. But this goes back to the first rule I taught, was you can do anything you want to an expression, into an equation, as long as you do it to both sides. So if I add 9 to the left side, then I must add a 9 to the right side, and everything balances out. So it truly is adding a 9 to both sides. Okay, so this side, we're going to rewrite it back as that x minus 3 squared. But the right side now becomes minus 6 plus 9, which is 3. Okay, and now we can use our square root property. So we can say, okay, to solve this, get rid of that 2 by square rooting. But then I have to square root the right side, add my plus or minus. The square root and this 2 will cancel, so I'm just left with x minus 3. And then I get plus or minus the square root of 3 over here. Last step is to add 3 to both sides to get rid of that 3 over there and isolate the x. So we get x equals 3 plus or minus square root of 3. And again, these are apples and oranges. You can't combine numbers with radicals. So your final answer would just be 3 plus the square root of 3, comma, 3 minus the square root of 3. Okay, number 8 is the almost the exact same, but what we had before was something equal a number, so we're going to move this 2 over to start. So we're going to have x squared plus 8x equals negative 2. And then I'm going to write this in factored form, x plus 4 squared equals minus 2. But we're also going to pick up a 4 squared over here. So we have x plus 4. I got that 4 by having the 8. Half of 8 is 4, so I put that in there, and then I have to pick up an extra 16. So we get x plus 4 squared equals 14. And now here's where we do our trick. So to get rid of that 2, we square root this side, add a plus or minus. So we get x plus 4 equals plus or minus the square root of 14. Now the factors of 14 are just 1 and 14 and 2 and 7. None of those four numbers are perfect squares. So it's not going to simplify, so we'll leave it like that. The last step is to subtract 4 from both sides and get x equals negative 4 plus or minus the square root of 14, comma, and those are the two answers you would type out. Okay, for 9 and 10, they want us to use the quadratic formula to solve this. And that's on the equation sheet you can use for the test that I have posted to Canvas, but I'm going to write it here. So if you have ax squared plus bx plus c equal to 0, you can solve for x using this formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is called the quadratic formula. And all you have to do is identify a, b, and c if you have it in the proper order. So notice this problem, it's in the proper order. You have your x squared first, then your x term, then your number, then equals, then 0. And we just have to recognize that there's a leading 1 there. So a is 1, b is 10, c is 21. And we just have to plug those into the formula. So we're going to have x is equal to minus b, or minus 10, plus or minus the square root of 10 squared, minus 4 times a, which is 1, times c, which is 21, all over 2 times a, which is 1. And we're going to get from this negative 10 plus or minus the square root. 10 squared is 100. 4 times 1 times 21 is 84. 2 times 1 is 2. Okay. This will give us minus 10 plus or minus the square root of 100. Take away 84 is 16, a nice perfect square. So we're going to get minus 10 plus or minus 4 all over 2. And this gives us two answers. One is minus 10 minus 4 over 2, and one is minus 10 plus 4 over 2. Minus 10 minus 4 is minus 14. Minus 10 plus 4 is minus 6. And these simplify to minus 7 and minus 3. So those would be our two answers. Okay, 10 is going to have us solve the exact same way with quadratic formula. And once again, I have a 1 in front of there, so that's a, b is 11, c is 5. And they've got it in the right order. They've got x squared, then x, then number, then equals, then 0. So we just need the formula again. So we have x minus b plus or minus the square root, b squared minus 4ac, all over 2a. And we plug in the numbers we have. So it's minus 11 plus or minus 11 squared minus 4 times 1 times 5 all over 2 times 1. And that's going to equal minus 11 plus or minus the square root. 11 squared is 121. 4 times 1 times 5 is 20. And that's all over 2. This would be minus 11 plus or minus the square root of 121 take away 20 is 101 all over 2. Now that's painfully close to a perfect square. A perfect square would be 100, which the square root of is 10, but we've got that pesky 1 there, so unfortunately that's not going to simplify at all. So 101 has no perfect squares hidden inside of it, so the answer is just, and be kind of a lot of typing, but you'll have to use the tool palette at the bottom of the homework. You'll type in minus 11 plus the square root of 101 over 2, comma, minus 11 minus the square root of 101 all over 2. So those would be your two answers. Okay, for problem 11, we're going to compute what's called the discriminant. Well, the discriminant is, we're going to label capital D, is just the square root portion of the quadratic formula. So it's that b squared minus 4ac portion. of the quadratic formula. Now, in the quadratic formula, it turns out to be the square root of that. So there's three possible things that can happen. If d becomes a negative number, then in the quadratic formula, you get the square root of a negative number. And if you get the square root of a negative number in that quadratic formula, then you're going to have two imaginary answers, two imaginary numbers for the result. Okay, if the discriminant is positive, then you get the square root of a positive number in the quadratic formula, and that's going to give you two unequal real numbers. So just like the previous problem, not the previous problem, the one before it, we had, it was the square root of 16. The 16 was positive, and we got two unequal real numbers. The answers were -3 and -7. So we got two real numbers that were the answer. Now this is a kind of a special case one. If d is 0, you get the square root of 0 in the quadratic formula, which is 0. So you just get one number plus or minus 0 over the bottom number, and that's going to be just one real answer. So kind of a special case. When the discriminant is 0, you only get one answer. One number pops out. Okay, so all we have to do is calculate the discriminant and see which one of these cases it is. So in this problem, A is 9, B is -9, and C is +9. So to calculate the discriminant, we take B squared, which would be -9 squared, minus 4 times A, which is 9, times C, which is 9, and we're going to get 81 minus 4 times 81, which is the same as -3 times 81, which is the same as -243. So our discriminant is a negative number, and if it's negative, that's going to be a negative square root in the quadratic formula, so we're going to get two imaginary numbers. Okay, so this one would have been if d was 0, this one is if d is a negative, this one is if d is a positive, and we won't have infinite solutions in the quadratic formula. You're only ever going to get two solutions. Okay, last problem in this set of notes. We have another discriminant problem. So we have A is 1, B is -6, and C is -6. And we said the discriminant is equal to B squared minus 4AC, the portion of the quadratic formula underneath the square root. And in our problem, B is -6, A is 1, and C is -6. So we get the discriminant is 36 plus 24, which is 60. And it's positive. So we have two unequal real solutions. So we get one solution if d is 0. We get two imaginary if d is negative. And we get two unequal real if d is positive. This one was positive, so we get that one. And you won't ever need this one. Okay, that would complete section 1.5.